In this tutorial, you will get introduced to Pytorch, a framework for building and training neural networks. Pytorch in a lot of ways behaves like the arrays you love from NumPy. These NumPy arrays, after all, are just tensors. Pytorch takes these tensors and makes it simple to move them to GPUs for faster processing needed when training neural networks. It also provides a module that automatically calculates gradients, which is important for backpropagation, and another module specifically for building neural networks. In this tutorial, you will learn some Pytorch basics, and you will train simple neural network on heart failure prediction. I'm using Google Colab here because I can access the free GPU from this drop-down list, change runtime, type, and choose this option because this is for free. This is paid subscription. Make sure you have a Google Drive account to get access to the folders and files by using these two lines. And here the path to the data folder, you can download it from my GitHub repo, which will find it in the description below. And here I am appending the file and folder that containing this folder. This is important when you are dealing with Google Drive and Google Colab. Now let's get into Pytorch basics. Well, it turns out neural network computations are just a bunch of linear algebra operations on tensors, a generalization of matrices. A vector is one-dimensional tensor. A matrix is two-dimensional tensor. An array with three indices in a three-dimensional tensor, like RGB color images, for example. The fundamental data structure for neural networks are tensors, and Pytorch is built around tensors. Here, some libraries, you need to import them. Specifically import Torch, which the package for Pytorch, and here the module NNN to build neural network using Pytorch. I'm setting the seed here to have the same output. Here I'm implementing the ReLU. My point is to show you how you can use Pytorch easily to implement ReLU activation function from scratch by this line of code, torch.maximum, and then the x torch.tensor. Here I'm implementing tensor of zeros, and here I'm implementing the sigmoid function using torch.exp, which is the formula of sigmoid activation function. Now let's try to use the sigmoid function to calculate output for a simple single layer network. Here I'm just generating synthetic data. This is features. I'm generating it from normal distribution, but notice that just with torch.randn. And here the weights, you can initialize a tensor in another way by passing the tensor that you have. For example, I have now features tensor. I can pass it with this method randn underscore like, and a bias term by this line of code, torch.randn. I want one point of bias because this is the single neural network. Here is the calculation how we can build single layer network by torch.matmul. This is for matrix multiplication because this is features a matrix and this is weight matrix, so we use this method from Pytorch package. Look how it's easy to use this package to deal with all of linear algebra stuff. Deep learning networks tend to be massive with dozens or hundreds of layers. That is where the term deep comes from. You can build one of these deep networks using only weight matrices as you did in the previous program, but in general it is very cumbersome and difficult to implement. Pytorch has a nice module which is NN. that provides a nice way to efficiently build large neural networks. In this problem, you will train a neural network to do exactly the same task. The data is saved in SFM light format under data path. By the way, SFM light format is just a sparse data representation format commonly used for machine learning tasks. Here, to load the data, and this is utils module. Also, you can find it in my Github Repo. You can download and upload it into Google Drive and save it in the same directory. And here the XTrain, you can have a look at it. And this is how we wrap tensors in a tensor dataset, because there are multiple tensors and we want to wrap them. We use this tensor dataset from Pytorch. Then you will load the dataset into data loader so that you can use it to loop through the dataset for training and validating. Here I have batch size. I will talk about what is batch size at the end of the video. And here I'm preparing the data loaders, which is important to loop through the data. Let's execute the cell. The batch size, the number of images we get in one iteration from the data loader and pass through our network. Here I'm iterating through the train loader to get the X and Y. X is the features and Y is the target. Here the steps to build the model. So I have a fully connected layer which has the input features and the output. Then a second hidden layer which contains the 64 and the output is 32. And this is drop out for this is like regularization to control the overfitting. Usually we use this point, this number 0.5. This is the output of a layer which is containing either the person has heart failure or not. So this is a classification problem. Then this is the forward. So this is the order of forward pass. This is fully connected. Then we apply Relio. Notice the torch. This is Pytorch library. Then the fully connected layer passes through Relio, and then drop out. Then the output using the sigmoid function over the fully connected third layer. And here we initialize the neural network. Model equals net. This is the information about model, how many layers, and the dropout, and this is the output with one feature, because I want to know either it has a heart failure or not. Relio is used for hidden layers. Notice that in hidden layer we use Relio here, but for the output usually we use sigmoid. Now we have a network. Let's see what happens when we pass an image. This is the output of the image. Now let's train the model. When we train, we calculate the loss by this criteria. Because this is a classification problem, we use this binary cross entropy loss, and then we calculate the optimizer using this optim from Pytorch, and here I'm using the stochastic gradient descent. Now let us train the NN model we previously created. We implement the evaluate function that we can evaluate the model before and after the training. Here, use that. Notice that we use torch and we use cat to make it into the GPU, the Y, true, and prediction, and this is the Y score. And here are the accuracy and precision, recall, F1. Those are the how I can like monitor the performance of the model. Here the performance about 60%. This is the accuracy. To train the model, this is the steps to train the model. First, we clear the gradients. The second step is to perform the forward pass that we mentioned before, model, and pass the input for the model. And step 3, calculate the loss using the cross entropy loss. And here the step 4, back propagation to compute the gradients of loss with respect to all parameters. And then we update the weights to have the minimum loss. And then I'm storing the loss in the list, train loss. Here, notice the accuracy is about 71. So we have better performance. Now, I want to mention two differences between the epoch and the batch size. An epoch is one full pass through the entire training dataset. If we have 1000 training examples, then one epoch equals model sees all 1000 examples once. If we have 5 epochs, the model sees all examples 5 times. In a single pass, the model often does not learn enough. Training for multiple epochs allows the model to gradually minimize the loss and improve accuracy. But notice that too many epochs can lead to overfitting. So what is batch size? Batch size is the number of samples that the model processes before updating its weights. So if data set has 1000 samples, batch size 100, then one epoch will have 10 batches. What happens in each batch? The model does a forward pass on 100 samples, calculates the loss, runs backpropagation, updates the weights. This process repeats until the model has processed the full data set one epoch, and then continues for the next epoch. The quick analogy, think of a full training dataset as a textbook. Epoch, reading the entire book. The batch, reading a few pages at a time before taking notes or updating your understanding.